Here are my solutions to the Mathematical Methods Examination 1 for VCE November 2024. Question 1. Part A. Let y equals e to the power of x cos 3x. The question is asking for dy by dx. We are going to use the product rule and the chain rule. So the derivative of e to the power of x is just e to the power of x times cos 3x plus e to the power of x, and now the derivative of cos 3x is negative 3 sine 3x. Part B. Let f of x equals log in base e of x cubed minus 3x plus 2. The question is asking to calculate f dash of 3. Step 1. Differentiate using the chain rule. So we are going to differentiate the inside function and then the log function. So this gives us 3x squared minus 3 over x cubed minus 3x plus 2. Step 2. Evaluate the derivative at x equals 3. So f dash of 3 equals 3 times 3 squared minus 3 over 3 cubed minus 3 times 3 plus 2. Doing all the calculations, we end up with f dash of 3 equals 6 over 5. Question 2. Consider the simultaneous linear equations given below. Determine the value of k, which is a real constant, for which the system of equations has no real solution. The system of equations has no real solution when the two lines are parallel. This means they have equal gradients and different y-intercepts. Step 1. Rearrange the two equations in the form y equals mx plus c. We start with the first equation, subtract 3kx from both sides of the equation, and then we divide both sides of the equation by negative 2. We rearrange it so y equals 3k over 2x minus k plus 4 over 2. We are going to do the same thing with the second equation. So this time we subtract k minus 4x from both sides of the equation, and then we divide both sides of the equation by k. So y equals negative k minus 4 over kx minus 1. Step 2. Equate the gradients of the two equations. This means that 3k over 2 equals negative k minus 4 over k. We cross multiply. So 3k squared equals 8 minus 2k. We rearrange to form a quadratic on the left-hand side, and then we factorize. Using the null factor law, we can solve for k, so k equals 4 over 3 or k equals negative 2. Step 3. Determine the value of k for which the y-intercepts are equal. For this, we are going to equate the y-intercepts. Doing the calculations, we end up with k equals negative 2. Therefore, for no real solution, we have k equals 4 over 3. Question 3. We are given the function g of x equals 1 over x plus 3 all squared minus 2. Part A. On the axis below, sketch the graph of y equals g of x, labeling all asymptotes with their equations and x's intercepts with their coordinates. First of all, we know that x equals negative 3 is the vertical asymptote, because when x equals negative 3, the fraction is undefined. Next, we know that y equals negative 2 is the horizontal asymptote. To determine the y-intercept, we are going to let x equal 0. So g of 0 is going to be equal to negative 17 over 9. We can plot the point and label it with the two coordinates, 0 and negative 17 over 9. Now we are going to calculate the x-intercept. Let y equal 0. So we have two solutions, x equals negative 3 minus root 2 on 2, or negative 3 plus root 2 on 2. We plot these 2 points and again we label them with their coordinates. Remember to always label the points with both coordinates. And we can now draw the truncus. Part B. Determine the area of the region bounded by the line x equals negative 2, the x-axis, the y-axis, and the graph of y equals g of x. In other words, the shaded region shown. The area is going to be integral from 0 to minus 2 of g of x dx. Note the change in terminals because the area is under the x-axis, so it's going to be negative and we want a positive area. Therefore, we calculate the integral from 0 to negative 2. We integrate and then we substitute the terminals and we end up with the area equals 10 over 3. Question 4. Let x be a binomial random variable where the number of trials is 4 and the probability of success is 9 over 10. Part A. Find the standard deviation of x. The standard deviation of x can be calculated using the formula square root of np bracket 1 minus p. We substitute the values we know and we end up with 3 over 5. Part B. Find the probability that x is less than 2. The probability of x is less than 2 equals probability of x equals 0 plus probability of x equals 1. We use the formula to calculate the two probabilities. And this gives us 37 over 10,000 or 0.0037. Question 5. We are given the function h of t equals 3000 over t plus 1 that models the population of a town after t years. Part A. Use the model h of t to predict the population of the town after 4 years. All we have to do here is just substitute 4 for t, and that gives us h of 4 equals 600. Part B. A new function, h1, models a population where h1 of 0 equals h of 0. But h1 decreases at half the rate of h at any point in time. The question is asking us to state a sequence of two transformations that maps h to this new model h1. We are going to use the first condition, which says h of 0 equals h1 of 0. h of 0 equals 3000, therefore h1 of 0 is going to be equal to 3000. Let's look at the second condition that says h1 of t decreases at a half the rate of h of t, which means that h1 dash of t equals a half h dash of t. We are going to rewrite the denominator of h of t as a negative power, so we can differentiate this function. Now we have h dash of t, which means that we have h1 dash of t, which is negative 1500 bracket t plus 1 all to the power of negative 2. We need to anti-differentiate h1 dash of t to determine h1 of t. Don't forget the constant of integration. We can now calculate the constant of integration, which is c equals 1500. So h1 of t equals 1500 over t plus 1 plus 1500. In other words, h1 of t equals a half h of t plus 1500. So the two transformations are a dilatation of factor of a half from the t-axis or parallel to the h-axis, and the vertical translation of 1500 units up. Part C. In the town, 100 people were randomly selected and surveyed, with 60 people indicating that they were unhappy with the roads. Part I. Determine an approximate 95% confidence interval for the proportion of people in the town who are unhappy with the roads. Use Z equals 2 for this confidence interval. Here is the formula for the confidence interval, where P hat equals 0.6 and Z equals 2. We substitute these values into the two formulas. We do the calculations. And we have 3 over 5 minus root 6 on 25 to 3 over 5 plus root 6 on 25. Part 2i. A new sample of n people results in the same sample proportion. Find the smallest value of n to achieve a standard deviation of root 2 on 50 for the sample proportion. We are going to use the formula for the standard deviation, and we substitute what we know, and we make this equal to square root of 2 on 50. We do the calculations, and we end up with n equals 300. Question 6. Solve the equation 2 log in base 3 of x minus 4 plus log in base 3 of x equals 2. First of all, we know that the 2 at the front of the first logarithm goes inside as a power of x minus 4. An addition of 2 logarithms is actually multiplying the quantities inside the logarithm. We expand the brackets inside of the logarithm, and now we know that x cubed minus 8x squared plus 16x equals 3 to the power of 2. We move 3 to the power of 2, which is 9, to the left-hand side of the equation, and we obtained a cubic equation. We are going to check the factors of negative 9, plus minus 1, plus minus 3, plus minus 9. If we substitute 1 into the equation, we obtain the answer 0, which means that x minus 1 is a factor of the cubic polynomial. We are now going to divide the cubic polynomial by x minus 1 using synthetic division. So first we drop down the coefficient of x cubed, which is 1. 1 times 1 equals 1. Negative 8 plus 1 equals negative 7. 1 times negative 7 equals negative 7. 16 minus 7 is 9. And then we have 1 times 9 is 9. Negative 9 plus 9 equals 0. So we can write the cubic as a product of a linear and a quadratic factors. We are going to use the null factor law. So we have x minus 1 equals 0, or x squared minus 7x plus 9 equals 0. From the first equation, we have x equals 1. And from the second equation, we use the quadratic formula to calculate the values of x. And that gives us x equals 7 plus or minus root 13, all divided by 2. Now we know that log in base 3 of x minus 4 is defined for x greater than 4, and log in base 3 of x is defined for x greater than 0, which means that both logarithms are defined for x greater than 4. Let's see where these two solutions are. We start with square root of 13, which is between square root of 9 and square root of 16. In other words, between 3 and 4. We add 7, so we have 7 plus 13 in the middle, and 10 on the left-hand side and 11 on the right-hand side. We divide these inequalities by 2, so we have 5 less than 7 plus root 13 on 2, less than 5.5. So this solution is part of the domain. It is greater than 4. Now let's try the second solution. So we start from the fact that negative square root of 16 is less than negative square root of 13, less than negative square root of 9. So negative square root of 13 is between negative 4 and negative 3. We add 7, and this gives us 3 less than 7 minus root 13 less than 4. Divide the inequalities by 2, so we have this solution between 1.5 and 2. We have to discard x equals 1 and x equals 7 minus root 13 over 2, since they are less than 4. Question 7. Part of the graph of f of x equals x sine x is shown below. Part A. Use the trapezium rule with a step size of pi on 3 to determine an approximation of the total area between the graph of y equals f of x and the x-axis over the interval 0 to pi. If we divide this area into 3 shapes of width pi on 3, we have a triangle, and then we have a trapezium, and then another triangle. The area of the trapezium is going to be equal to a plus b multiplied by h over 2, where h equals pi on 3. So we are going to write the area of the triangle plus the area of the trapezium plus the area of the second triangle. We do the calculations, and we end up with an answer of root 3 pi squared over 6. Part BI. Find f dash of x. We are going to use the product rule again to differentiate x sine x. F dash of x equals 1 times sine x plus x cos x. Part 2i. Determine the range of f dash of x over the interval pi on 2 to pi on 3. For this, all we have to do is substitute the two ends into the equation of the derivative. So f dash of pi on 2 equals 1. And f dash of 2 pi on 3 equals root 3 over 2 minus 2 pi on 3. Let's check whether root 3 on 2 minus 2 pi on 3 is negative or positive. So we try less than 0. We move the second term to the right-hand side of the inequality. We cross multiply, and we square both sides of the inequality. 27 is definitely less than 16 times 9.8596. Therefore, root 3 on 2 minus 2 pi on 3 is less than 0. So the range of f dash of x is from root 3 on 2 minus 2 pi on 3 to 1. Part 3i. Hence, verify that f of x has a stationary point for x within this interval. Since the range of f dash of x starts at a negative value and ends at a positive value, there must exist a value of x within this interval for which f dash of x equals 0. Therefore, f of x has a stationary point for x in the interval pi on 2 to 2 pi on 3. Part C. On the set of x's below, sketch the graph of y equals f dash of x on the domain minus pi to pi, labeling the endpoints with their coordinates. You may use the fact that the graph of y equals f dash of x has a local minimum at approximately negative 1.1 and negative 1.4, and a local maximum at approximately 1.1 and 1.4. So first of all, let's plot these 2 points, the local minimum and the local maximum. And now we calculate the value of f dash of x at the 2 endpoints. So f dash of pi equals negative pi, and f dash of negative pi equals pi. We can now plot the function f dash of x. Question 8. We are given the function g of x equals the cube root of x minus k plus m. Let the point P be the y-intercept of the graph of y equals g of x. Part A. Find the coordinates of P in terms of k and m. For the y-intercept x equals 0. Therefore, g of 0 equals the cube root of negative k plus m. So, point P has coordinates 0 and the cube root of negative k plus m. Part B. Find the gradient of g at P in terms of k. We are going to write the cube root of x minus k as x minus k to the power of a third. We differentiate g of x and then we calculate g dash of 0, and that is a third minus k to the power of negative 2 over 3. Part C. Given that the graph of y equals g of x passes through the origin, express k in terms of m. This means that g of 0 equals 0. Therefore, negative k to the power of a third plus m equals 0. Negative k to the power of a third equals negative m, which means that negative k equals negative m cubed. In other words, k equals m cubed. Part D. Let the point Q be a point different from the point P, such that the gradient of g at points P and Q are equal. Given that the graph of y equals g of x passes through the origin, find the coordinates of Q in terms of m. Let's have a look at the graph of g of x. The point in the center of the cubic graph has coordinates k and m. We know that point P has coordinates 0 and 0. If we look on the x-axis, the distance between P and C is k, which is m cubed. Is going to be exactly the same as the distance between P and C, which is k equals m cubed. And this happens because the 2 points are equally distant from the center C. So the x-coordinate of point Q is 2m cubed. We are going to do the same thing on the vertical axis. The distance between P and C on the vertical axis is m, and the same with the distance between C and Q on the vertical axis is m. So the y-coordinate of point Q is 2m.